Let S sub 1 equals this. Here, what you got to pay attention to is that we have the set of xy coordinates that satisfy this inequality. So this is going to be an area of some sort in 2D, right? Because it's x and y, so it's 2-dimension. And there's inequality, so you would be shading something, right? And the same goes for this, is another shading of something. What the shape is, we got to explore and find out. What they are looking for is the ratio of the area of S2 to area S1. So shall we find what these are? What is this? This reminds you of a circle, but it's got log and constant and all those things. Let's see what they are. So I will copy the problem down. Log 10, 1 plus x squared plus y squared is less than equal to 1 plus log base 10 of x plus y. Okay, we don't like dealing with log. The only way to make this make log disappear is to combine them, both sides, into a single log. And adding 1 is not a cool thing. It just refuses to combine. So instead of 1 here, I will trick it and say, oh, it looked like 1, but actually it was a log base 10, log 10 base 10. This is 1, isn't it? So I want to write it that way. Why? Because I can, and also that's the only way to correct this. I got to have one single log on each side. Why? Because I want to get rid of it. And you will see why it disappears. There we go. And this side, you know the property of log. When you add two logarithms of the same base, you multiply what is inside. I want to say it's a logarithm, but I'm not sure if there's a such term. So anyway, so whatever it's called, whatever is inside, I will call it logarithm today. So I am multiplying the logarithms. Okay, now what's the big deal about combining them into a single log? Logarithm is a monotonically increasing function. That is, it never goes up and down. It just goes smoothly up like that. So if it was a bigger number here, if I raise to the 10th power, 10 to that power, it remains a bigger number than this. Okay? That's because the exponential is also monotonically increasing here. If I have the same base, bigger exponent would give me bigger number. If you go bigger exponent, it will be bigger number, right? So compared to the smaller one, smaller exponent gives you smaller, bigger number gives you bigger number. So 10 to that. As you know, I carefully chose this base 10 with the sole purpose of getting rid of this annoying log. That's why we had to combine into 1, because I couldn't do it without turning into log first. Okay, I could have, but bear with me. So here we go. So I got 1 plus x squared plus y squared is less than or equal to 10x plus 10y. Okay, now let's find out what these are. Now it's really, you have a strong smell of a circle, right? So x squared minus 10x. You know why I'm leaving the space there, right? Minus 10y less than equal to -1, right? I just shuffle these guys over there and 1 to here. You may say, what kind of strange manipulation is this? Nothing special about it. All I did was I just, spaced them suspiciously. And then I moved this constant to the other side. You may be suspicious, but you agree this was legal, right? I am going to add 25. Of course, I got to add on both sides. I'm adding 25. I got to add on both sides. Okay. Now what? What do we get? Here, I just complete the square. Realize? So let me put the results here. Would be x squared, not squared, minus 5 squared plus y minus 5 squared is less than or equal to 50 minus 1 is 49. Very interesting. Very, very interesting. Okay, this is a circle centered at 5, 5, but we don't care because all we care about is the area that we are going to talk about. So this is r squared, as you know, so area will be this 49 pi will be the area. Okay, so for S1, the area is 49 pi. Okay, we're all set with that.